Although steganography content can be hidden in text files, HTML web pages, executable files, even file systems, the most popular type of carriers are digital images and audio files. Let's look at the steganography techniques used in digital audio and video carrier files first. A WAV file is a digital audio file format identified by a file name extension of WAV. It is a list of uncompressed samples after digitalizing an analog sound wave. Each 16-bit sample value represents an amplitude value of the analog message. Based on Nyquist-Shannon sampling theorem, if each sample is collected at a frequency of 44.1 kHz or 44.1 K times per second, the digitalized analog audio will sound similar to the original analog sound wave. So, digital WAV files are commonly large. MP3 is another popular audio coding format for digital audio. It uses a form of data compression to reduce file sizes, typically by the factor of 10 to 14, in comparison with a WAV file without noticeably affecting the sound quality for most listeners. Unlike WAV files, MP3 is encoded in modified discrete cosine transformation coefficients, not amplitude value. When using least significant bit to hide payloads in a WAV file, the raw sample or amplitudes, LSBs, will change slightly, but humans are insensitive to these insignificant changes. A steganography tool called S-Tools can hide payloads in WAV files. When applying LSB encoding to MP3 audio and MP4 video files, it changes the carrier's coefficients, LSBs, to hide a payload. MP3 Stego will hide information in MP3 files during the compression process by modifying the MP3 encoding algorithm to insert data. The data is first compressed, encrypted, and then hidden in the MP3 coefficients. MP4 Stego hides data in MP4 video files. Steganography in digital audios and videos is dangerous, since it has the potential to conceal a great quantity of information in large-size carrier files. In addition, people often exchange audio and video files to play them in YouTube, MP3 and MP4 players, and smartphones. Detecting steganography files from a large number of audio and video files is difficult. Detecting steganographic files from a large number of audio and video files is difficult. How are steganographic technologies applied to digital images? Digital images are made up of pixels. We will look at 3 types of images based on how they present color digitally. In palette images, each pixel is represented by 8-bit binary data. Each 8-bit is mapped to one predefined color out of 2 to the 8th power, or 256 colors. Since each pixel holds one color, and there are only 256 different colors to choose from, the palette images are small and low-resolution files. GIF file is an example of a palette image. In two-color images, each pixel holds a color triplet of red, green, and blue, representing the color intensity, with 8 bits for each color. Therefore, the total combination of possible colors is 2 to the 8th times 2 to the 8th times 2 to the 8th. This ends over 16 million possible colors. People also call this type of image 24-bit true color. Although true color images are more accurate than palette images, their file size is much larger. Both bitmap image and a ping are true color images. To reduce image file size, people have tried to compress digital images. After the lossy compression process, some insignificant information is discarded. Therefore, the original image is no longer fully recoverable. JPEG images are lossy compressed images. More specifically, JPEG images do not store the individual color value for each pixel. Instead, the JPEG compression algorithm uses discrete cosine transformations, or DCTs, to transform every 8 by 8 pixel blocks of the image into 8 by 8 DCT coefficients. Therefore, JPEG reduced the image size. Although some information is lost during the compression process, human eyes cannot see noticeable differences. When applying least significant bit encoding to true color images, there are only subtle changes to each pixel of the original image. Therefore, the change is undetectable through visual inspection. S-tools used in wave-file steganography can also take true color images such as bitmap and ping images as carrier files to hide other images or files. The resulting covered image using S-tools is the same size of the carrier image. To convince you that human eyes are not sensitive enough to detect the color differences, we generated 6 different colors using Dreamweaver. Can you see the difference in color, although multiple least significant bits were changed? When applying least significant bit encoding to the lossy compressed images like JPEG images, LSB modifications are made to the coefficients of the DCT prior to the compressed stage. The popular tool JP Hide and Seek, also known as JPHS, is an example using this approach. Even though JPHS uses a substitute steganography method, the size of the covered message is usually smaller than the original carrier JPEG image due to an additional compression process. Another artifact of using JPHS is that the header information of the covered JPEG image is usually stripped, while the carrier image has the JPEG header information. Give It Up steganography software is a free program that allows you to hide information in a palette image, such as GIF images. It first sorts the 256 colors in the palette so that the closest colors fall next to each other. Similar colors are paired up. One color represents digit 1, while the other in the pair represents 0. For example, we put 2 close red colors together. R0 represents 0 and R1 represents 1. The hiding process starts by using the closer sets of colors, assuming I need to hide a 0 bit in a red pixel. If the pixel is currently R0, which represents the correct bit, it remains untouched. Otherwise, if the pixel is currently R1, we change it to R0. Since R0 and R1 are a pair with a similar color, this change is not noticeable to human eyes. The main advantage of this type of tool is its simplicity. Also, since palette-based images are usually low in quality, any minor changes may not be detected. However, this method does not allow us to hide large amounts of data. To detect this type of tool, investigators should check for similar colors. Having pairs of close colors is an indication of using this type of steganography tool. So far, we have introduced 4 free steganography tools. Knowing which carrier files each tool supports helps investigators narrow down the suspicious images for investigation. For example, if an investigator detects S tools installed on the suspect machine, he or she should pay more attention to GIF, bitmap, and WAV files for possible steganography content, since S tools use these 3 types of images as carrier files. In a summary, S tools uses GIF, bitmap, and WAV files as carrier files. GIF-it-up only use GIF image as its carrier file. JP hide-and-seek only uses JPEG image files as their carrier files. And a camouflage can use any types of carriers. Although I only introduced a few, there are many free and commercial steganography tools are available for use. Some tools like OpenPuff can combine several files together as a carrier file to hide payload. With the wide use of smartphones, a set of new steganography apps have emerged. These new apps run on Android, iOS, and Windows mobile platforms. Most of them use Stego technologies similar to what we saw in this video. For example, the iPhone Stego tool, SpyPix, uses LSB to hide Stego contents. In the next video, I will show you how to use S tools JP hide-and-seek and a camouflage to hide or unhide data.